This is the brief on the distinction between mathematical nothingness and physical transparency in tensor physics. So we're going to dive into a really crucial idea in electromagnetism. We're going to clear up why the mathematical zero isn't the same thing as empty space when we talk about how electric fields actually move around. Okay, first up, the mathematical definition of nothingness is the zero tensor. Imagine a tensor as this multidimensional tool that shows how forces travel. Well, the zero tensor is just pure mathematical annihilation. Every single one of its components is zero. If an electric field hits this thing, it's just gone. It just ceases to exist. But, of course, that's not what happens in reality. So, second, physical transparency, like a vacuum, is described by something called the identity tensor. This model shows how free space lets electric fields pass through completely unimpeded. It keeps the field's original direction and strength perfectly intact, and it's scaled by a constant, epsilon naught, which basically just tells you how easily an electric field can form in that empty space. And finally, this is why it's so important. Using the zero tensor to model a vacuum would totally contradict what we see in the real world. It would literally mean that no electric field could travel through it at all. This is way different from dielectric materials, right? Those things only reduce an external field by creating their own internal field. They don't completely annihilate it like a mathematical zero implies. So in physics, nothing lets fields pass, but zero makes them vanish.